harder trigonometric identity proofs. So we're just going to look at some harder trig identity proofs. And yeah, we'll just have a look at a few examples. So let's have a look at prove sine 2 theta cos theta minus cos 2 theta sine theta all over cos 2 theta cos theta plus sine 2 theta sine theta all equals tan theta. Now, good strategies for these is always dealing with the ugly looking side, which is obviously the left hand side, and doing as many obvious things as we can. And one of the obvious things is we have some double angles on the left, but only a single angle on the right. So we want to go ahead and change all of our expressions to involve single angles. So sine 2 theta is 2 sine theta cos theta, all times by cos theta, minus cos 2 theta. We've got a few expressions we can write for cos 2 theta, but we've got cos squared theta minus sine squared theta. We've got 2 cos squared theta minus 1 and 1 minus 2 sine squared theta. And the one we actually would most likely be nicest to use is one that's not involving sine, because if we expanded the sine with it, we'd end up with cubes. So we want to just express it in terms of cos. So we can express it as 2 cos squared theta minus 1 times sine theta. So this way we're not going to get any cubes involved. With the other two we would, because they're not as nice to deal with. And again, we have our cos 2 theta down the bottom, and it's being multiplied by a cos theta. So this time we want to express it in terms of sine squared. So this cos 2 theta we might express in 1 minus 2 sine squared theta times cos theta, plus sine 2 theta is just 2 sine theta cos theta, and that's all being multiplied by sine theta. So let's tidy this up. So we're going to have 2 sine theta cos squared theta. Now let's go ahead and expand all this. So we've got minus sine theta times 2 cos theta. That's going to give us minus 2 sine theta cos squared theta. Now we've got minus sine theta times minus 1 is going to give us plus sine theta. It's going to be all over. 1 times cos theta is just cos theta, minus 2 sine squared theta cos theta, expanding that out, plus 2 sine squared theta cos theta. After expanding, we can see we have some pretty nice things that we can do. We can see that 2 sine theta cos squared theta minus 2 sine theta cos squared theta will just cancel out. Then in the denominator, minus 2 sine squared theta cos theta plus 2 sine squared theta cos theta will also cancel out. And we're just left with sine theta over cos theta, which equals tan theta, which equals our right hand side. Let's have a look at another example. So this time we want to prove that sine 3x over sine x minus cos 3x over cos x equals 2. Now, we can write into better expressions for sine 3x and cos 3x using our compound angle results. So we'll take our left-hand side, and we can rewrite these as sine of 2x plus x all over sine x minus cos of 2x plus x over cos x. So let's go ahead and expand those out. So we're going to get sine 2x cos x plus cos 2x sine x all over sine x minus cos 2x cos x minus sine 2x sine x all over cos x. Then we can use our double angle results to expand the sine 2x and cos 2x's. So we're going to get 2 sine x cos x times cos x plus 1 minus, we might express it in terms of sine for now, 1 minus 2 sine squared x sine x all over sine x minus cos 2x. Well, let's express this one in terms of cos because we have a cos in the denominator. So we're going to get 2 cos squared x minus 1 times cos x, and the sine 2x we can write as 2 sine x cos x all multiplied by sine x all over cos x. Now we can do some simplifying here. We can factorize out a sine squared, a sine x in the numerator to cancel out with the denominator. So the sine x, and sine x will all cancel out here. And on the right, the cos x, and cos x will all cancel out. So we're left with 2 cos squared x plus 1 minus 2 sine squared x minus, now everything on the right has to be subtracted, minus 2 cos squared x minus 1 minus 2 sine squared x. We can tidy this up. Let's just expand our bracket first. So we get 2 cos squared x plus 1 minus 2 sine squared x minus 2 cos squared x plus 1, so expanding that minus out, plus 2 sine squared x. Now 2 cos squared x minus 2 cos squared x cancel, minus 2 sine squared x plus 2 sine squared x cancel, and we're just left with 1 plus 1, which is 2, which is our right hand side. Let's look at one more example. We're going to prove that sine x plus sine of 90 minus x plus 1 all over sine x minus sine of 90 minus x plus 1 equals cot of x over 2. There's a couple ways we could do this. We could use t formula because we have a half angle of this, but let's attempt it without t formula. So we're going to take our left hand side, and first let's change those sine of 90 minus x's because sine is complementary with cos, so we can rewrite this as sine x plus cos x plus 1 over sine x minus cos x plus 1 is sine of 90 minus x just equals cos x. Now we're going to rewrite these doing a bit of a trick. So we can rewrite sine of x as sine of 2 times x over 2. Because if you just multiply that, that'll just equal x. This is going to help express it in terms of a half angle. So we're going to do this for all these angles. So then we're going to get cos of 2 times x over 2 plus 1 all over sine of 2 times x over 2 minus cos of 2 times x over 2 plus 1. And now we could actually rewrite these with double angle formulas because it's 2 times some angle. So that's what we're going to do. So we can rewrite this as 2 times sine of x over 2 cos of x over 2 plus, we have a double angle involving cos. You have to rewrite this as 2 cos squared of x over 2 minus 1 for our double angle formula for cos plus 1 all over 2 sine x over 2 cos x over 2 minus, now again we have a double angle formula for cos, and this one we might write in terms of sine, so it's 1 minus 2 sine squared of x over 2 plus 1. So we can tidy this up a little bit. So let's just simplify a bit. So we'll have 2 sine of x over 2 cos x over 2 plus 2 cos squared x over 2, and minus 1 plus 1 will cancel out. All over 2 sine x on 2 cos of x over 2 minus 1, expanding the minus, plus 2 sine squared x over 2 plus 1, and the minus 1 and plus 1 will cancel out here. In the numerator, we can take out a factor of cos of x over 2, and that'll leave us with 2 sine, so we can take out a 2 as well actually. So let's do that. We'll be left with sine of x over 2 plus cos x over 2 all over. Again, we can take out a factor of 2 sine of x over 2 this time. And if we do that, we're left with a cos x over 2 plus sine x over 2. Sine x over 2 plus cos x over 2's will cancel. The 2's will cancel. And now we just have cos over sine, which is just cot x over 2, which equals the right-hand side.